Welcome everyone. In this video, we're going to implement a conversational LLM-powered chatbot with memory. This chatbot will be able to have a conversation and remember the previous interactions with a chat model. So your user will be able to have a conversation with the model will respond, and the conversation context will be kept. And we're going to see how we can implement that using LangChain. This tutorial will cover the basics, which will be helpful for any advanced topics that we're going to cover in later videos. Let's take a look at the requirements that we need in order to get started. So, of course, we're going to need Python. So if you don't have Python, you can download it from python.org. I'm going to be using Visual Studio Code, which you can also download for free if you don't have it. And also feel free to use any IDE, will also work. We are going to be using OpenAI for our model, but you can also use Groq Cloud, and I'm going to set it up for both. We're going to install the dependencies that we need for both. And then I'm going to show you how you can initialize the Groq Cloud. And then I'm going to continue using the chat model from OpenAI. So everything will be the same. I'm just going to show you how to bring in both packages, and then you choose the one you want to continue with. Now let's jump right into creating a project directory and setting up the virtual environment. So I'm going to create a new folder on my desktop. So let me move this to the right. And right on my desktop, you can create your folder anywhere you want. I'm just going to do it here on my desktop. And let's call this folder LangChain-chatbot. And then I'm going to open this folder with VS Code. And let me bring that over to this window. There we go. Let's put this side by side. Cool. All right, so in here, we're going to create a new file, and we're going to call this one requirements.txt. Requirements in here. And then I'm going to paste all the dependencies that we're going to need in here. So feel free to pause this here and copy all the dependencies in here. So we have from LangChain, we're going to have LangChain, LangChain-graph, LangChain core, the community, and then we have the separate package for OpenAI and Groq. You can pick which one you want to use in here. You don't need to install both, but I'm going to do both so I can show you how to initialize both of these and use the one you need. Then for the UI, we're going to use Streamlit to build the prototype UI. And then we're going to use .env to load all the environment variables. So once we save this, we can open the palette. So let's go into, let's press Control-Shift-P to open the palette. And then we need to search in here for Python create environment. So you will probably have to search for that, but I see it in here, my recently used here. And then we're going to pick this venv to create a virtual environment. And by the way, if you don't see this here, I'm going to press escape in there. You want to make sure you have the Microsoft Python extension. So if I search for Python here on the extensions that I have, you should install this one as well, because this one has all the necessary tools that we need to work with Python in VS Code. So make sure you have that one installed. And then I'm going to go back in here and do Control-Shift-P again. Click on Create Environment. And then I'm going to select venv. And then choose your latest Python interpreter version here. Once you click there, you're going to see that Python is going to pick up and say, okay, do you want to use the dependencies in here that you have listed? So we're going to select that and click OK. This is going to probably take a couple of minutes, but it's going to set up your virtual environment. and it's going to install all these dependencies inside of this virtual environment, and then we're going to continue building the application. So we see the folder here, and it's just going to take a couple of minutes. So I'm going to pause here and continue when this is done. All right, now that our virtual environment is created, we're going to close this up, and we're going to create a new app.py. And we also want to, let's create a new .env file so we can add our environment variables in here. So the environment variables, we have to go and get it from Groq Cloud. So you can go to console.groq.com. You can log in or sign up so you can go and grab your API keys. So let me just log in really quick. All right, so now that I'm logged in, I can go into API keys, and you can create a new API key if you don't have one. And then we're going to copy the API key and bring it over to the environment variable or to the .env file. So in here, we're going to need let's create a environment variable here. And this one's going to be our Groq underscore API underscore key. Once you create your API key, you're going to paste it in here inside of those quotes. And we're going to do the same with the OpenAI. So we're going to do OpenAI underscore API underscore key that you can get from your API, from your OpenAI account. So for that one, you have to log in into, you can go to platform.openai.com, and then here you can log in. Let me see if I can log in on this one as well. Let me refresh it here, try to log in. All right, so I'm logged in now. You can go to API keys in here, and you can create a new API key as well here, and then copy and paste it over to the quotes in here. I'm going to copy mine, and then I'm going to continue with the video. So let me pause here and update these two. Okay, perfect. So that has been saved, and we are good to go and get started with the app in here. So let me go back to here. And the first thing we're going to do here is going to import, let's import from .env. Oops, let's just do that again from .env, import load.env. And this one is going to, we just need to call this so we can initialize all the environment variables inside of this file. So we're going to go ahead and save that. And then we're going to bring in, let's bring in both, I'm going to bring in both OpenAI and the Groq Cloud. So I can show you how we can call the model. Let's say from, let's do LangChain OpenAI, import ChatOpenAI, and for Groq will be basically the same. Import Groq, ChatGroq in here. So you can see it's basically the same thing. Now we're going to create our model. Let's do the model down here. So let's say model equals, and then let's start with the OpenAI. So we're gonna call chat OpenAI in here. And if you're using Groq, you can just call it ChatGroq. And then here we need to pass the model that we want to use. And for the OpenAI, we can pass in quotes here. Let's pass GPT-40-mini, or if you want to use a different one, you can use a different one and make sure this is an O, not a 0. Cool. And then if you're using ChatGroq, you can do basically the same. So let me just bring this in again, copy this down so I can toggle that back in here. And then we're going to just replace this with the ChatGroq. And then here we can pass the model as well. And then we can find the model that we want to use from the playground. So let me close this up and go to the playground here real quick. Playground here. And then in the playground, you have all of these different models that you can use. So the default is Llama 3.37b, but you can pick any of these that you want. So let's pick in here. Let's do, well, why not? Let's do that one. That's fine. So let's do Llama dash 3.3 dash 7db dash versatile. Cool. And then go ahead and save that. So Llama 3 dash and then 7. There's no, okay, that looks a little weird here, but that's how it is. 3.3 dash 7. Okay, cool. So this is how you would do it if you're using Groq, right? So we're gonna go ahead and test this really quick and say completion is going to be equals completion equals, and let's call the chat, or let's call the model dot invoke, or invoke the model here. And here, if we look at what this is expecting some input. The input is, so the input to the runnable. So normally we will send an object that it looks similar to this here. Let's take a quick look at this. So for the messages that we normally send, they are a dictionary just like this one. And we have three different types: the system, the user, and the assistant, right? So they have the row and they have the content in here. If you're using the LangChain, you're going to have three different kind of like documents that you can use, or not document, classes for each message. So we have a class for the system message, the human message, and the AI message. So the way that this works, we have, normally we used to have a dictionary with the row system. In LangChain is called the same system message. For a user message, in LangChain they call it human message. And then for the assistant, they call it an AI message. So we're gonna go ahead and import this three right now so we can start looking at these different type of messages. So let me just bring the space here. And in here, let's import, let's say from, and let's import that from, let's do LangChain core. So LangChain core dot, and then we need to go to messages. And then we can import the human message. That's the one we're gonna use right now, but let's import the AI message, and let's import the system message right away so we can have all three in there. Now let's use the human message to pass a message to our model. So we can call the human message class in here. And then here we need to pass a message or some content. So in here, we're going to just say content equals, and then let's just say hi. Let's say, hey, what's up? In there. And then we're going to print the completion. Now let's open up a terminal. Let's save that and open a new terminal. You can click here, click terminal, new terminal. And now let's hide all this that we don't need. Now in here, let's see, my terminal is still loading. There we go. Let's do an ls. This is so slow right now. What's going on? Let's try that again. Come on, come on. ls, here we go. Cool, okay, I see my app and I see my requirements. Okay, my computer's a little slow already, so let's go and type in here. Let's do Python and then app.py. Let's run it or press enter here. Okay, give me a little error here. It's here, the input, did I pass this wrong? Oh yeah, because we need to pass this in here. So I forgot to wrap it up in a list. So let's do square brackets and then pass the human message in here. So let's go ahead and save that and try it again. And we should see the completion now. And here we go. We have the completion output in here. We can see that we have a content from here. We can access content. It says not much. And then the response is here. And then we have all this metadata about the response. So in here, let's just put this in the next line so we can see that better in here. We need to pass to the model a list of messages, right? So normally you will have in here a chat conversation. So here, this is a list of messages. So you can have like a system message, which basically set the persona of the model. And then you can have like a user message, another a system message, which is the response right now. So this will be a list of messages that we need to always send. So we're gonna keep that in mind there. And then we're going to do the same. Let's just, this one, I'm just going to comment this out and then bring this one back in and run this again. So you can see that it's basically the same thing. But now I'm going to show you the response from ChatGPT. Here you go. And the response from ChatGPT is saying, hello, I'm here to help. Any question, blah, blah, blah. So basically you have another, the same property content with the response. And then you have all the metadata about how many tokens and the reason why it finished, because it stopped generating in here. But basically all the metadata you need about the response is there. So for our conversation, we need to keep building these lists of messages, right? Human message, a AI message, which we can use from LangChain in order to pass the corresponding class of messages or type of message. So what we're going to do next is that we're going to create in, let's bring in LangChain. Let's do Streamlit. So let's say let's do import Streamlit as st. And we're going to initialize a list of messages for basically the chat history. So all the messages are going to go into a list. So we're going to say if chat_history is not in st.session state. So we're going to create a new property on the session state for Streamlit, so we don't lose the data when the app kind of like refreshes or rerun. And then we're going to do colon here. So if it's not in the session state, we're going to create it. So we're going to say st.session state dot chat history or chat_history that is going to be equals to a list. And here's where we're going to place all of the messages just like we do in here in this list here. So in here, instead of doing this, let's go here and let's say st.session state chat history append, and then here we're going to pass the human message, and we're going to ask, let's pass the content, and let's just ask what is the capital of France. And instead of passing the list in here, we're going to just pass in here st.sessionState chat history. Cool. So now we're going to be adding the messages to the session state chat history list, so that way we don't lose data. And here we're adding a new message. So we are appending a new message here, and then we pass in the chat history to the model. We invoke the model, and then we're going to get the completion. So let's run this one as well to see the response from OpenAI. Okay, so here, what do we have here? Oh, now that we have OpenAI Streamlit, we can run the app directly, but we can see the content here. It says the capital of France is Paris, and all these warnings that we got here is because now that we have added Streamlit to the project, we can just run Streamlit instead of Python directly, but we still got our response in here. So let's run the app. Let's do Streamlit run app.py, and then this is going to open up a new browser window here, running our server. So that way we don't get the warnings. So right now we don't have anything there, but we can go in here and say let's do a simple, why don't we start with just a title. So let's see that title, and this is just going to render a title and say LangChain Chatbot. And at the top here on the right hand side, there's a button that says always rerun. So click in there so you can refresh the app. We can see the title in here now. We can also add a header, so st.header, just to say something else, and we can say conversational model with memory. So we can have a title in there, and let's have a divider, and we're going to just make it red in here. Cool. So that's good for the UI. We're not going to do much in this first part. So let's go back in here. So we can print it, and we can also write it to the app in here. So we can do st.write, and we can pass it the completion.content. And then now we can see the capital of France is Paris in here, right? Because our app refreshes and it runs again with the same prompt. So cool. So now we have Streamlit, we have our LangChain in here, we have our chat history inside of the session state. We have our models. We can try this out with this model and see with ChatGroq to see the response. So this is going to refresh. So pretty much we got the same response in here. Cool. So feel free to use whichever you want. I'm going to keep the OpenAI, and I'm going to be using ChatGPT 4o mini. So now let's continue with the next step. So we're building this chat history, right? So the first thing we do here is when we get the prompt, we're going to append it to the chat history. And right now, this is basically the message we get back from the model. So we also need this response, this content, to be added to the list of messages. And for that one, we're going to be using, let's go in here and say st.sessionState.chatHistory. data pen. And here we're going to use an AI message. And we're going to set parentheses content. And here we're going to pass the completion data content. If we want to see all the messages now, not just the response, so if we want to see the user too, we could just, let's say, instead of just doing this one, we could do a quick for loop. So for message in st.session_state dot chat_history. We can go ahead and let's do the st.write, and we can pass the message in here. So let's wait for the app to refresh, and message the content. All right, so right now the app has reloaded multiple times, so we have all of these chats in here. Let's just give it a quick refresh. So let's go and see what's the capital friends, and then the model will respond, and we have the chat history in here. Now we're going to make this look a lot better. Right now I'm just iterating in here and just printing the content, but we're going to create the different messages, and they're going to have their icon for the corresponding message if it's a user or an AI message as well. All right, so right now we have the chat history being stored inside of the session state of the application. And this is basically serving for us to display the chat messages in here, but we also want to keep this chat history in the model's memory. And for that, we're going to have a different approach, and we're going to introduce what's memory and what's the state graph, so we can create a graph that is going to remember the messages. And we're going to do that using LangChain in this section here. So let's start by importing what we're going to need in here. So at the top here, we're going to import the memory saver. So we're going to say from LangGraph dot checkpoint and then dot memory. We're going to import memory saver, which is the memory we're going to pass to our graph, and then we're going to say from LangGraph, we're going to import, let's do dot graph, so we can import, we're going to import star, comma, and then we're going to import message state and the state graph. So we're basically going to combine all of these 4 different components in here, so we can build a graph which is going to have our message state and is going to have memory, so you can remember all of the different messages from the conversation. So let's go right after the chat history here, and we're going to initialize a new memory and we're going to save the reference into the session state. So we're going to say if memory not in st.session state, we're going to do st.session state memory. We're going to initialize that to calling the memory saver, right? So that way we don't initialize multiple ones if the app reruns. So we're just going to have one instance of the memory saver. And let's click here. It says always rerun in here. And then we can continue down here. So let's say we have the memory now that we need to pass to our graph. So we need to go down here and create the graph now. So right after the model here, let's go and initialize our graph. So we're going to define a new graph. And we're going to call this variable, you will see that variable called workflow. So we can initialize our workflow first. We're going to say workflow is equals to StateGraph. And then we need to pass the state schema. And the state schema is going to be the messages state. So the graph is going to have messages inside of the graph. Now we're going to define a action. So we're going to say def in here, call, so a little function call underscore model, which is going to be our action that's going to be called whenever we run our graph. So here we're going to receive the state, which is going to be messages of type messages stay here. And then down here, we're going to invoke our model. So we're no longer going to invoke it from here. So we're going to do it from inside of this function. So we're going to say, let's say just response or completion, doesn't matter. Let's do completion equals to model.invoke. And we're going to pass the state messages, right? Because the messages from the graph is going to be passed to the model, and the model is going to send our messages, is going to receive our messages, and is going to inference the next response or the next message. So here we just need to return a object with messages and set that to the completion. Cool. So now in order to basically set up the, set up the nodes on the graph. So we initialize the graph here, but then we need to make sure we connect our nodes from the graph. So we're going to here create, let's do create a new node on our graph. And then here we're going to say workflow, which is basically our graph that we're putting together. And we're going to add a edge, so that, or a connection. So add underscore edge. And to that, we're going to pass the start key. So we're going to use the constant that we imported at the top, this one here, star, so we can mark the star of our graph. So star. And then we want to, the next one we're going to put is the end key. The end key, we're just going to say model. So we're doing a connection to our node, and then the actual node is going to be added now. So workflow dot add underscore node. And the node we want to add it to the model, to the edge here with the key model. And then we want to pass the call model action, or pass the action. So here we need to take it and we pass the key or the name of the node and the action that we can call on that node. So everything we need to set up on our graph is already created here. So we create the graph, create the action, and then connect everything up in here. Now we can compile our graph, and so we can run it. So we can create a runnable graph. So or we can call it how many, as soon as we get a new prompt. So let's do, let's just call it runnable underscore graph. And we're going to set that equals to workflow dot compile in here. And then to the graph, now we can pass a check pointer, which is going to be the memory. So a check pointer saver object or flag, which is going to be used as a short-term memory for our graph, allowing us to be able to pause, resume, or replay from any point. So here, what we're going to pass is to check pointer, to check pointer here, we're going to pass the st.session state that memory that we created at the top. So now we have this runnable graph in here that we're going to use in order to pass the different messages, and that's where LangChain is going to keep all the memories, and we can manage our memory size from there. And we can there's different strategies that you can use. We're going to use one later on so we can manage the size of the conversation, because the problem is that if the conversation gets too big and then this it goes out of the maximum token for the context that the model can receive, then we're going to have a problem. So in order to manage the size of the conversation, we're going to be using different strategies later, or one or two that we can use. But basically here our graph is already set up and ready to use. So let's go down here right after the runnable graph that we created. And here, let's create a input for in the app. Let's do a text input for the prompt. So let's create a variable called prompt, and we're going to initialize it here right away. And we're going to do st.chat input, chat underscore input. And then here, let's just move all of this, indent this in here really quick, and go ahead and save it. Make sure we can see this here. Cool. So now in here, everything inside of this if statement here is going to run when there's a new prompt in the input. So right now we don't see any completion running right now. So that way we have already our chat input, and then we loop over the message in here in a second. So in here, let's see what's going to stay in here. So whenever we have a new prompt that is passed into the input message here, it's going to be available inside of this variable called prompt. So instead of passing this string here with the same prompt every single time, we're going to just pass prompt. And then what else? In here, we have the completion, which is fine. But let's do, yeah, we can keep the word in here, completion. But now we don't longer want to invoke the model by itself. We want to invoke our runnable graph, right, which has the memory. So if we delete this here and we say runnable graph that invoke, then we're going to hit enter here, and we're going to pass the in a property called messages, we want to pass the new message, and we also need to pass basically a ID or a thread ID for this conversation. So here the input is going to be a dictionary with a string, a config with the configuration for this conversation or this code that we're going to do. So let's do a dictionary here, and we need to pass messages and then colon, and we're going to pass our human message here now. And on the human message, we want to pass content equals prompt. So remember, this one is just keeping the information for the chat here so we can see it, but this call here is passing the same prompt to the actual model or to a runnable graph, which is going to keep these messages manageable inside of the memory. And then as the second parameter after this here, we need to pass a configuration object for the for this call here. So it's an optional. This is the configuration for the graph to run, but let's do it in here. Let's do it outside in here. So here we're going to say let's say graph config, and we're gonna say, let's call config in here equals, and then this is going to be an dictionary with a configurable property, and then we just need to send right now the thread ID. So this is the thread or the conversation thread that we want to keep. So here, thread underscore ID, and then here we can pass any ID. That could be any random generated ID, but we're just going to initialize it to 1 for now. But you can use any library like UUID to pass a unique ID for the conversation. Now that we have this config here, we can pass it down here. We can type config. That's good. And I think that's everything we need to pass in here at the moment. Now down here, let's go and print. Instead of printing just the complete, well, yeah, we can print the completion. Let's do, we don't need to call it directly. We can do completion, because now this completion, we can do completion, square brackets, quotes, square brackets, quotes, messages, square brackets -1 to get the last message, and then we can call it that pretty underscore print, so we can see it in the console. And then we can just go and loop over the messages that we have and render them inside of the app. But in order to do that a little bit more nicely, we're going to go and delete this here. And let's do a with statement for a st.chat message. So it can be inside of a chat message. Element. So let's go in here, chat message, and then in here we're gonna check if, so right now, let's see. So for chat message, we can pass the name, which is only user, assistant, AI, or human. So let's see, user. So could be human as well. So name, user, assistant, AI, human. Okay, so we could do, let's say human if instance of, or is instance, and then we pass the message, and then we pass human message in here. So we're going to check if the message is an instance of a human message, we want to pass human, and then else we want AI. And let's see what, oh, I need to do colon, and then here, so that's the element that we want to render. So it's going to be either human message, a human element, for the UI or a AI element for the UI, so we can see it. And then inside we're going to do st.write, and then we're going to pass the message.content and go ahead and save that. Cool. So now we have our chain, which is now runnable, and anytime we get a new prompt, we're going to invoke a runnable graph with the new message, right? With the new prompt here. And we want to append it here so we can see it before we loop over that. And then we can also see it in the console here. So let's say, hey, what's up? And it says object has no attribute content. Where is this happening? Let's scroll down. And as the content, completion of that content here. Let's bring this down. In here, completion. Okay, yeah, so that is because now it's not completion of that content anymore. It's basically this right here. So we basically need to pass completion messages and then grab the last message here. So we can just grab this and we can just put it, replace completion. We can leave the dot content because we need that at the end. So it will be completion, square bracket messages, -1 for the last message, and the dot content. Save it, and let's try that again. Let's just say, hey, what's up? Okay, cool. So now we have a bunch of messages here. Let's refresh, but we can see we have the elements are working. Let's refresh the app. So we wiped out the chat history and the memory. And let's say, hey. And there we go. We got the hey from us, from the prompt, and then the model responded, hello, how can I assist you today? Let's say, tell me a joke about programmers. There we go. Why do programmers prefer dark mode? Because light attacks bugs. Okay, it's a pretty good one. Cool. So now we have basically a working chatbot. So now we're going to take a look at the code in here just to see what really is going on behind the scene of this workflow that we created, this runnable graph. And let's see what else can we implement now that we have a LangChain and all of the different components available here. So in here, just to highlight the memory part of the application here using this memory that we have. So we create our graph. This is our action. We create the connection on our graph, and then we pass the memory to our workflow when we compiling it into a runnable graph that we can now invoke with messages here. So I'm going to say, let's say, hey, my name is Abe. Okay, so it responds, it knows my name right now. So if I go here and change this thread ID to 2, save it, and I'm going to go ahead in here and just say, hey, what is my name? It says, I'm sorry, but I don't have access to personal data about individual unless you share that information with me during this conversation. Now, it doesn't know my name because I changed the thread ID, but if I switch it back to this one here, and I go and say, what's my name? It knows my name. right? Now this one remembers my name because we are storing that information into this short-term memory for the model to remember our conversations. And now we can create like multiple chats by passing a new ID for each of the conversations that we create and remember the other ones. So let's make this chatbot a little bit more functional. So remember, we still have like a system message, which is going to allow us to set the persona of the model. So we can just say like, hey, you are a helpful assistant or something like that. Or we can give it a really weird persona like a pirate or something like that. So we're going to try that next so we can see how we can create a prompt template and combine a system message and then create our conversations with a human AI message and one single system message all together. So let's go all the way to the top again. And right after this last import, we're going to say from LangChain core, and then dot prompts. We want to import the chat prompt template down here, and we also want the message placeholder. Now we're going to scroll down to, let's say, right before we create our model here. Okay, so let's do some comments here. This is our model or LLM. Then we have here our chat prompt template. In here, let's just do it like this. So we're going to create a variable called prompt template. And this is a template that we're going to create and then pass the new messages into this template. So we're going to call chat prompt template and hit enter here. So this is going to have a list of messages, right? So we're going to start a list of messages here inside of this prompt template. And then here we can set a system message. So the system message, well, not system error, but system message in here. So this system message is going to help us kind of like set the persona of the model. And here we're going to set content equals to, and here we can pass a prompt. So for the prompt for the system message. So here we're gonna set it to, you can set it to anything you want, but let's just change it to like to talk like a pirate, so we can see if it stays into the role that we're giving the model here. So let's say you are a personal assistant that talks like a pirate, right? So that's the system message. Here we can put all the information about how we want the model to behave, right? So we're telling, hey, you are a personal assistant, but you also talk like a pirate. So let's see if that works. And then here we're gonna put a message placeholder in here. So the message placeholder is for us to pass the messages. So this is just a placeholder where the rest of the messages are gonna go. And here we basically just need to create a variable or just pass, say, variable name in here of messages. So we can pass the messages in here. Right, so this create a new model by parsing and validating input data from the keyword assignment. So basically the messages that we passed in already, we already have the model and everything set up. We just need to combine this prompt template that we're building with our model in here. So let's go and scroll down to here. So we want to basically invoke the template first before we get the completion. So here, let's go ahead and hit enter. Let's say prompt. Let's say prompt. Yeah, not prompt, because it's gonna say, it's gonna be confusing. So let's do chat underscore template messages equals, and then here we're going to call our prompt template, and we're going to invoke the chat prompt template, invoke, and we're going to pass our state, right? This state of messages that we have in memory in our graph. So here we're going to pass that into the chat prompt template, and those messages are going to go into this messages placeholder. So we're going to have the system message always there, so we can keep the context and then pass all the messages from the state into this message placeholder. And then instead of calling model.invoke state, we want to invoke it with the chat template messages. And then we're going to just get the completion, and that will stay the same with the response. So now let's save that. Let's go ahead and refresh the browser here. And let's say, hey. And there we go. We have a system message, which is token just like a pirate. So you can see in here, we have, oh, there. So cool. So you can set, basically anything you want in here. You just wanted to make it a little fun and see if we stay inside of the context here. So right now we're responding. Let's say, tell me a joke about pirates. Okay, there we go. So why do pirates shower before walking down the plank? Walking the plank, because they would just wash up. Cool. All right. So it's doing good so far. So right now we have a new prompt template, which we have now our system message. We can personalize our model, and then we have our messages placeholder where we pass in the state messages, and then we invoke in our model with the chat template messages, and then we get in our completion back. So nothing else has changed here. So that will be fine. That's all we got to do there. Now, the last thing I want to show you is coming back to managing our chat inside of LangChain. So right now, our chat can grow and grow and grow still, and we're keeping that into memory. The memory is more efficient, but it has different strategies that you can use. And one of the most famous one is basically trimming older messages. So the messages that are really old could be trimmed off the conversation, or we'll keep any amount of messages that we want the model to remember, so that way we don't go outside of the context window that the model has, and then that way we can keep our conversations going. So to trim our messages, we're going to go ahead and import. So we're going to say from a LangChain core dot messages. Do we have messages already? We do. LangChain core messages. We already have that import up here. Let me see if we have the trim messages here. So this trim messages is a function, trim messages to be below a token count. So it will help you trim messages and keep a token count. Trim messages can be used to reduce the size of a chat history to a specified token count or a specified message count. So we're going to use the message count we want to keep, so that way we never run out of context, out of the context window. So we're going to bring in the trimmer, and we're going to go down to here right after the prompt template. Here we're going to create messages trimmer, and we're going to say trimmer. In here, we're going to set that equals to trim messages, and we're going to set the strategy we want to use. Strategy. Wait. Oh no. What am I typing? Why is this not coming up? Okay, why is that coming up? Am I calling the right function? Trim messages in here. Okay, this is not coming up. Okay, let's just keep typing in. Okay, didn't come up, but let's set that equals to last. So we want to keep the last messages using this strategy here. It doesn't give us any information right now, but let's hover over this, see if there's any useful information here. So argument messages, the max tokens, the token counter, the strategy here. So first or last. So last, keep the last n count tokens of the messages. The default will be last, but you can change it to first if you want, or some other option in here. A start on message if you wanted to as well. But we want to, in here, keep the last message count. And here you can say max underscore token, which is basically how many messages we want. We can set it to 50. And then the token length underscore or token counter. We're going to pass it just length here. So you can use the length from our messages, and then include system here. So include underscore system is the option to keep the system message. So I do want to keep the system message, so we can keep the context in here for being a pirate. Let's click always rerun here at the top, but basically there's more options, but we're using the strategy last, so we can keep the last 50 messages, and we can include the system message as well. So you can play around with the max tokens for the messages count and the other values in here. I will drop a link, but here's the link to read more about that, and I will also drop some links in the video description so you can read more about trimming messages strategies in there. So how do we set this up? Now that we initialize it, we need to trim our messages before we pass it to the prompt template. So we're going to come back to this call model function, and here we're going to create a variable trim messages equals, we're going to call our trimmer. And of course we're going to we need to do trimmer.invoke, and then in here we're going to pass the state square brackets messages, and here we need to pass it like that. We cannot just pass state like we can do to the chat to the prompt template. So now that we pass in the state to the trim message to the trimmer is going to just keep the last 50 messages in here, and those last 50 messages what we want to pass to our chat our prompt template here. So instead of state here, we're going to pass our trim messages. And then the prompt template will have those messages, and we can invoke the model with those 50 or whatever value we set amount of messages. So now that is already set up in there. So we are always going to have that set amount, and we can just test the model again. So let's say, hey, let's just say, what are you up to? See what it says. Okay, we got an error here. Max token, trim messages, got an unexpected argument max token. Do you mean max underscore token? Okay. No, that there's something wrong. Max tokens, but I don't know. It was just save it because it wasn't giving me the autocomplete, but that's fine. Let's say, what are you up to? Okay, so we see we have the previous conversation. What are you up to? What are you up to again? Because we got an error earlier. I'll be here, ready to assist you. Okay, there we go. So we got the pirate assistant in here. So we still have that. So in order for testing this will be that we can have a really long conversation, and it's always going to give the system message, right? So it's going to have this persona that you're setting here, or the instructions that you put in here, and then it's going to keep the last 50 messages so it knows about the conversation. Now you can set that number to higher. It is up to you. We just set it to 50 here, as just try to keep it small, but you can test it out with smaller or bigger values as well. And then for finishing up the chatbot, right now, if we look at the UI, so right now we are good with the memory part and all of that is completed. But just as the last thing, what I would like to do is to, instead of waiting for the whole entire message to come back, right? Because we see, let's say, tell me another joke. We can see that we still here waiting, and then when you finish generating the whole response, is that we see something here. So normally you see the streaming of the messages, of the chunk of the messages, and that's what I would like to do last for finishing up the chatbot. So that way we have a better UI for our users to see the text stream instead of just waiting at a blank screen and then getting the response a few seconds later. So let's work on that, and then we'll finish up the chatbot. All right, so inside of the if statement here, let's see, let's move up the for loop to be all the way at the top here, so we can loop over the messages right away, because we're going to be adding a placeholder for the completion. So I want to render everything first, and then let's see, we can keep that there. Then in here, so we're going to say this is for UI messages in here. Now this here is just going to, let's do append user prompt to chat history. Cool. So now in here, we want to show right away, we want to show the new user message, the new one that the user is typing here. So we're gonna go a little bit of space here. So let's do a with state that chat message Here we're gonna pass human, and we're gonna do st.write, and then we're gonna pass prompt, right? And I'm doing this because we need to handle the previous messages. So, and then the new message. So let's say previous message. This is the new message, and this is all for the UI. New message, all these changes is for the UI to work with the streaming part. So we have the previous messages, we append the new, oh wait, it says, okay, we append the new message to the chat history, we show the new message, and then what else we gotta do? So now, this completion, before the completion, we want to create a placeholder for the AI or the new AI message. What happened here? And here we're gonna do with. Let's do st.chat message. And here we're gonna put assistant. And because we're going to be streaming the chunks of text, we want to first, let's create a variable here. So full underscore response. It's going to be start as an empty string. And then we want to, let's say, concatenate. So we're going to have to concatenate the message to this string because we're going to get the chunks of text. Now, inside of here, inside of the actual message, we want to put a placeholder. So placeholder equals, we can use st.empty for that. So we just create kind of like an empty container. Placeholder. Cool. Now that we have the placeholder, we want to now grab each chunk of the message. So here, let's see, we want, so we got the completion here, but now we no longer wants to use that one. We want to, let's see here. Yeah, let's comment this out. We can delete it. I'm just gonna comment it out for now. You can delete it whenever you're ready. So here we're gonna say for chunk, comma. We can also grab the metadata. We don't need the metadata, but you can have it in there. In, if you need to read it and console log it. Metadata. And then we're going to call a runnable graph in here. We're going to stream. So this time we want to invoke it. We want to stream the message in here. So this stream method is going to allow us to stream the chunks of the completion, right? So from the response that we're getting back. So every single time, so in here we call in the method. So we need to pass this here. So we need to pass the dictionary with messages, just like we were doing here before. And then we want to pass the human message again here. Inside of the content, we want to send the prompt. The prompt. Yeah, so this prompt here, just like we're doing before, and then comma, and then config. So this is the same there, but now we're going to set the stream mode to messages. And then we're going to do, let's see, so messages. Wait, I closed this too far off. Oh no, that's fine. That's fine. We can keep it there. So this can just close right here. then colon, and then in here, we are inside of that for loop. So here, what we want is we want to concatenate to the full response the chunk dot content chunk, right? So each chunk that we get is going to have the content. So whatever text we get in each chunk, we'll concatenate it to this full response variable here. And then we're going to access our placeholder, and we're going to call the write method on the placeholder, which is allowing us to write something to this empty placeholder that we created here. And we're going to pass the full response and save that. Okay, now I don't need this anymore. Can get rid of that. And let's see down here. So here we were doing the appending of the completion. So instead of doing all of this here, nope, just all of this here, we want to pass the full response to go inside of the AI message, but it needs to be outside of the for loop. That's good. And this print, we can print the response if we want, or we can print anything we want in here, but we could just print the full response in here too. And that's it. Now we should have streaming set up in here. So let's see, let's test it out. Let's say, hey, okay, human message error here. Let's see what it says here. Unhashable type, human message in here. Human message, content prompt. What am I doing here? This is a dictionary, so this is wrong here. So colon. Let's say, are you there? Okay, and you saw that how it was streaming the response in there. Let's say, write a story, so it could be something long, about a pirate AI bot that pirate AI robot that loves adventure. Okay, it's a little, what's going on? Okay, it was streaming it. Yeah, the stream is working. It's just like the UI in here was a little flickering. So let's say we were streaming the messages in here. That's good. Let's say, tell me a joke. Okay, there we go. Cool. So now your streaming is set up. Now you have a better UI that the user can see the streaming of the chunks, and it doesn't have to there and wait until the full response is generated, which is a better UI experience overall. So now our chatbot is complete. You have created a chatbot with memory that can remember the conversation. You implemented a trimming strategy for keeping the context of the conversation manageable, so you can play around with this number here to increase it to more messages if you want. And basically we use multiple components. Here you can change the thread ID for some unique ID if you want to have more unique IDs for your conversations. And basically whatever you pass in here will be a brand new conversation in here. So you can ask, what's my name? not gonna know. Don't have that, but if we go to the chat one, was my name. Because I refreshed earlier, probably it refreshed the browser. I refreshed the browser a couple of times, so we lost that first conversation there. But if you ask anything else about this latest messages about the story that we just executed now, it should remember that in there. So let's say, give me a summary of the story about the robot. Okay, there we go. And it knows what we're talking about, and it gives back the summary of the story. Perfect. So I hope you like this one. This is going to be something that we're going to be using when we start building AI agents, which a lot of these components are going to come in and help us out to build more intelligent AI applications. So thank you for watching. I'll see you in the next one.